Hi, welcome to this new episode. We were discussing about configure and manage virtual networks for Azure administrators. We have discussed virtual networks, network security groups, Azure DNS, Azure network, virtual peering. Now we'll be working on configure network routing and endpoints topic. Let's start it. Introduction. In this module, suppose your company recently suffered a security incident that exposed customers' personal information. This security incident has resulted in the loss of customers' confidential data and confidence. To address this scenario, the IT team has recommended implementing network virtual appliances. You need to ensure traffic is properly routed through the virtual appliances. You are exploring other security options like service endpoints and private links. Review system routes. Azure uses system routes to direct network traffic between virtual machines, on-premises networks, and the internet. Information about the system routes is recorded in a route table. Things to know about system routes. Let's take a closer look at how Azure implements system routes. Azure uses system routes to control traffic for virtual machines in several scenarios. Traffic between virtual machines in the same subnet, traffic virtual machine in different subnets, in the same virtual network, traffic from virtual machines to the internet. Okay. Virtual machine in the same subnet, different subnets, same virtual network, machines to the internet. Okay. A route table contains a set of rules that specifies how packets should be routed in a virtual network. Route tables record information about the system routes where the tables are associated to subnets. Each packet leaving a subnet is handled based on the associate's route table. Packets are matched to routes by using the destination. The destination can be IP address, virtual network, gateway, a virtual appliance, or in the internet. When a matching route cannot be found, the packet is dropped. Business scenario. Suppose you have a virtual network with two subnets. In this configuration, you can use Azure system routes to control communication between the subnets and the internet. A front-end subnet can use a system route to access the internet. Okay. A back-end subnet can use system route to access the front-end subnet. Both subnets access a route table. The following illustration highlights this scenario. Identify user-defined routes. Azure automatically handles all network traffic routing, but in some cases custom configuration is preferable. In this situation, you can configure user-defined routes and next hop targets. Things to know about user-defined routes. Let's examine the characteristics of user-defined routes. User-defined routes control traffic network by defining rules that specify the next hop of the traffic flow. The next hop can be any one of the following targets: virtual network gateway, virtual network, internet, network virtual appliance. Similar to system routes, UDRs also access route table. Each route table can be associated to multiple subnets. Each subnet can be associated to one route table. Each subnet can be associated to one route table only. Each route table can be associated to multiple subnets. There are no charges for creating route tables in Microsoft Azure. Okay. Business scenario. Suppose you have a virtual machine that performs a network function like routing, firewalling, and WAN optimization. You want to direct traffic traffic to NVA, network virtual appliance. To accomplish this configuration, you can place an NVA between subnets or between one subnet to the internet. The subnet can use UDR to access the NVA and then the internet. The subnet can use another UDR or NVA to access the backend subnet. The following illustration highlights this scenario. Determine service endpoint uses. A virtual network service endpoint provides the identity of your virtual network to the Azure service. After service endpoints are enabled in your virtual network, you can secure Azure service resources to your virtual network by adding virtual network root to the resources. Today, Azure service traffic from a virtual network uses public IP address as a source IP address. With service endpoint, service traffic switches to use virtual private addresses as the source IP addresses when accessing the Azure service from a virtual network. This switch allows you to access the services without need for reserved public IP addresses that are typically used in IP firewalls. Things to know about service endpoints. Review the following characteristics of service endpoints. Service endpoints can extend your virtual network identity to your Azure resources to secure your service resources. You secure Azure service resources to your virtual network by using virtual network rules. Virtual network rules can remove public internet access to resources and allow traffic only from your virtual network. Service endpoints always take service traffic directly from your virtual network to the service on the Microsoft Azure backbone network. Service endpoints are configured through a subnet. No extra overhead is required to maintain the endpoints. The following illustration shows virtual machine connecting to the Azure service through service endpoint. A virtual machine in a subnet accesses an Azure storage account to service endpoint. Virtual network rules allow the virtual machine to access the Azure service resources but not communicate with the internet. Okay, virtual network, storage, virtual machine, service endpoint. Okay. Things to consider when using service endpoint. There are several scenarios where using service endpoints can be advantageous. Review the following points to think about how can implement service endpoints in your configuration. Let's go from bottom to top. Consider easy configuration and maintenance. Configure service endpoints in your subnets for simple steps and low maintenance. You no longer need to reserve public IP addresses in your virtual networks to secure Azure resources through IP firewall. There are no NAT or gateway devices required to set up the service endpoints. Consider direct traffic to the Microsoft network. Use service endpoints to keep traffic on Azure outbound network. This approach allows you to continue auditing and monitoring outbound traffic from your virtual networks through forced tunneling without impacting service traffic. Consider optimal routing for service traffic. Routes in the virtual network that force internet traffic to your own premises or network virtual appliance also typically force Azure service traffic to take the same route as the internet traffic. This traffic control process is known as the forced tunneling. Service endpoints provide optimal routing for Azure service traffic to allow you to circumvent forced tunneling. Consider improving security for resources. Implement service endpoints to improve security of your Azure resources. When service endpoints are enabled in your virtual network, you secure Azure service resources to your virtual network with virtual network rules. The rules improve security by fully removing public internet access to resources and allowing traffic only from virtual network. With service endpoint, the virtual machine IP addresses switch from public to private IP4 addresses. Existing service firewall rules that use Azure public IP addresses stop working after the switch. Ensure Azure service firewall rules allow for the switch before you set up the service endpoints. You might also experience temporary interruption to service traffic from the subnet while configuring service endpoints. Determine service endpoint services. It is easy to add service endpoints to virtual network in Azure portal. You select the Azure service for which you create endpoint. In this unit, we examine several services including Azure Cosmos DB, Event Hubs, Key Vault, SQL databases. Adding service endpoints can take up to 15 minutes to complete. Each service endpoint integration has its own Azure documentation page. Azure storage generally available. All are generally available in all Azure regions. Azure storage can support up to 100 network rules. SQL database, data warehouse, single databases and elastic pool in SQL database, Azure databases in SQL data warehouse, Azure databases for Postgres and MySQL, Azure Cosmos DB. Okay. Only the endpoints also allow you to restrict access to a list of IPv4 address ranges. Azure Service Bus. Identify private link uses. Azure Private Link provides private connectivity from virtual network to Azure platform as a service, customer-owned or Microsoft partner services. It simplifies the network architecture and secures the connection between endpoints in Azure by eliminating data exposure to the public internet. Things to know about Azure Private Link. Azure Private Link keeps all traffic on the Microsoft global network. There is no public internet access. Private Link Global is global and there are no regional restrictions. You can connect privately to services running in other Azure regions. Services delivered in Azure can be brought into private virtual network by mapping your network to private endpoint. Private Link can privately deliver your own services in a customer's virtual networks. All traffic to the service can be routed through private endpoint. No gateways, NAT devices, Azure Express or VPN connection or public IP address are required. Following illustration demonstrate a network routing configuration with Azure Private Link. The service connects a network security group private endpoint by using SQL database. Its configuration prevents direct connection. Private endpoint SQL database. Network security group private endpoint by using Azure SQL database. Okay. Things to consider when using Azure Private Link. Let's go from bottom to top. Consider services delivered directly to customer virtual networks. Privately consume Azure PaaS, Microsoft Partner, and your own services in your virtual networks on Azure. Private Link works across Microsoft intra-tenants, AD tenants to help unify your experiences across services, send, approve, reject, request directly without permissions, role-based access controls. Right? Consider productionized data exfiltration for Azure resources. Map private endpoints or Azure PaaS resources. When there is a security incident within your network, only mapped resources are accessible. This implementation eliminates threat of data exfiltration. Consider integration with on-premises and peer network. Access private endpoints over private peering or VPN tunnels from on-premises or peered virtual networks. Microsoft hosts the traffic, so you don't need to set public peering or use the internet to migrate your workloads to cloud. Consider private connectivity to services on Azure. Connect privately to services running in Azure regions. Traffic remains on a Microsoft network with no public internet access. Interactive lab session. The most amazing session I enjoy. Create and configure virtual network in Azure. Create and configure virtual networks in Azure. Deploy two virtual machines into different subnets. Okay. Ensure that virtual machines have public IP addresses that won't change over time. Okay. Protect virtual machines in public endpoints from being accessible from the internet. Ensure Azure virtual machines names IP addresses can be resolved. Ensure publicly available domain name can be resolved by external queries. Oh, it's a big architecture. Task 1, task 2. Let's see them by tasks. Okay. IP addresses and access. Create and configure virtual network in Azure. Create virtual network, VNet 1, 2 subnets. Okay, we know this. Deploy virtual machines into different subnets of virtual network. Okay, we'll create virtual machines. So task 1, task 2. Okay. Configure private and public IP addresses of virtual machines. Ensure the IP addresses don't change over time. Associate the VM0 NIC with a static public IP address. VM1 NIC with a static public IP address. Configure private and public IP addresses. Public IP address, public IP address. Private and public IP address. Here only public he mentioned. Fine. Let's go forward. Configure network security groups. Protect the virtual machine public endpoints from being accessible from the internet. Okay. Well, configuring network security groups, we know that. Configure Azure DNS for internal name resolution. Ensure internal Azure virtual machine names and IP addresses can be resolved. Add virtual network link in virtual network. Verify virtual machine DNS records are registered. Great. Internal DNS name resolution is working. Yes, we worked till here last time only. In our previous labs, we completed till task 5. Configure Azure DNS for external name resolution. Ensure publicly available domain name can be resolved by external queries. Okay. We have been asked to implement the following requirement. 2 virtual machines. Public IP addresses that won't change over time. Okay. Public endpoints from being accessible from the internet. Okay. Network security groups. Azure virtual machines names IP addresses can be resolved. Okay. Azure DNS internal name resolution private DNS zone. Okay, here public it's a private. Let's see how it goes.
Welcome to this interactive lab simulation for the lab In this lab, you will complete the tasks listed on your screen. In this first task, you will create a virtual network with multiple subnets by using the Azure portal. Follow the prompts to In the toolbar of the Azure portal, search for and select Virtual Net. Create a virtual network that will have multiple subnets. Add the first subnet. Click Review and Create. Click Create to submit the deployment. When deployment completes, in the left pane, next, click Subnet and add a second subnet to the newly created virtual network. This task is now complete. Click the screen to continue. In this next task, you'll deploy Azure virtual machines into the different subsets of the virtual network by using an Azure Resource Manager or ARM template. In the toolbar of the Azure portal, select PowerShell. Click Show With an existing resource group selected, provide names for the storage account and file share. Click Create Storage. In the toolbar of the Cloud Shell, click Upload and upload the loop parameters and loop template JSON files into the Cloud Shell home directory. Open the loop parameters file in the editor and change the password. Save the change. Next, run the commands as shown to deploy 2 virtual machines using the uploaded JSON files. Close the Cloud Shell pane. This task is now complete. Click the screen to continue. In this next task, you'll configure static public and private IP addresses assigned to network interfaces of Azure Virtual Machines. Follow the prompts to complete this task. On the blade of the virtual network, click Connected Devices. 2 devices are connected to the virtual network. Select the first one. Click IP config. Select IP config 1. On the IP config 1 blade, select Next, click Create New and add a public IP address as shown. On the IP config 1 blade, keep the default value of the IP address and click Save. Navigate back to the virtual. Select the second device. Click IP config. Select IP config 1 and then repeat the steps to associate a public IP address. This task is now complete. Click the screen to continue. In this next task, you'll configure network security groups to allow for restricted connectivity to Azure Virtual Machines. Follow the prompts to complete this task.
Let me verify the task 3 once again.
This task. Click IP. Select the Navigate back to the. Keep on the IP. Next, on the. Select IP. Click IP2 on the blade. In this next task, you'll configure static public and private IP addresses assigned to network interfaces of Azure Virtual Machines. Follow the prompts to complete this task.
Here it is mentioned private and public IP addresses, but we'll be doing only operations for public IP. Let's check.
On the blade of the virtual network, 2 devices are connected. Click IP select on the IP config 1 blade, select Next, click Create New and add a public IP address as shown. On the IP config 1, keep the default value of the IP address and click Save. Navigate back to select the second. Click select IP config 1 and then repeat the steps to associate a public IP address. This task is now complete. Click the screen to continue. In this next, navigate to the Virtual Machines blade. Select the first virtual machine. Click Connect and then select RDP. Using the public IP, click the link to open the file. Next, click Connect. Next, navigate to Network Security Groups and create a new security group.
We are unable to access the virtual machines, so we are creating network security group.
Click Go to Resource. Add a new rule explicitly allowing inbound RDP traffic from the Internet. Add the rule. Next, select click Associate. Associate the network security group with each network interface in the list. Next, navigate back to the virtual machine. Select the first virtual machine and connect with RDP. Use the public IP address and start the remote desktop session. Sign in with the user and password in the parameters file. Minimize the RDP window. This task is now complete. Click the screen to continue. In the Azure portal, search for and select Private DNS Zone. On the Private DNS, provide the project and instance details as shown. Click Review and Create. Click Create. Click Go to Resource. Under Settings, click Add, and then create a virtual network link. Select the checkbox to enable auto-registration. Refresh the page. In the left pane, select Overview. Search for and then click Windows PowerShell. Select Run as Admin. In the Windows PowerShell console, run the commands as shown to test internal name resolution in the newly created Private DNS Zone. Verify that the output of the command includes the private IP address of the second virtual machine. Minimize the RDP window. In the Azure portal, search for and select DNS Zone. On the DNS Zone, provide the project and instance details as shown. Proceed and create the DNS Zone. Click Go to Resource. Click Record Set. Add a record set that uses the public IP address of the first virtual machine. Next, add a record set that uses the public IP address of the second virtual machine. Copy the name of name server. Next, open Cloud. In the PowerShell console, run the command as shown to test external. Verify that the output of the command. This interactive lab simulation is now complete.
Great. We successfully completed the lab simulation. We have to do at least 3-4 times. Then it would be very easy next time. Your company needs to extend their private address space in Azure by providing direct connection to Azure resources. Your IT team needs a list of valid next hop types. The infrastructure team has requested an overview of Azure routing capabilities and requirements. Which statement will describe Azure routing? Azure gateways. This one is the correct answer. When next hop is none, traffic will be dropped. What is a valid next hop type? Internet won't be. Express route won't be. I think let's check with load balancer. How can you extend the company's private address space with direct connections to Azure resources? Virtual network endpoints. How can you extend the company's private address space with a direct connections to Azure resources? Virtual appliances, right? God. Correct. The valid next hop choices are virtual appliances, virtual network gateway, virtual network, internet, and none. Okay. Valid next hop choices are virtual appliance, virtual network gateway, virtual network, internet, and none. Where did he mention the documentation? Where did they mention? Okay, next in virtual network endpoints extended. Let virtual appliances are traffic control and high availability. Virtual networks are extend private address space in Azure. Endpoints restrict the flow of traffic. Service endpoints are created. Azure creates routes in the route table to direct the traffic. That's fine. We need to reload it again. We'll do that. Which statement which describe Azure routing? This one is correct. What is a valid next hop? Internet. How can you extend the company's private address space with endpoints? Check answer. Amazing. Let's go to the summary. For use virtual network. No. Oh, we got only very less summary. Network routes control the flow of traffic to your network. You can customize these routes, implement service endpoints, and work with private links. In this module, you learn how to implement system routes, user-defined routes. You identified features and usage cases for Azure Private Link and endpoints. You explored how to configure custom route and discovered how to work with service endpoints. Maybe. Great. That's it for today. We will connect in the next session. Thanks for watching. Have a good day. Bye.